Perfect. Then also welcome from our side. We are really happy to be here today and talking about the replacement, the hardware replacement of headlight leveling sensors and also tire pressure sensors with AI. When I'm speaking of we were already introduced, Raphael Fitzek, our co-founder and CTO at COMPREDICT, and myself, Stefan Hassels. I'm head of product at COMPREDICT, and we will guide you through the next 30 minutes of the presentation, or 25, and then hopefully you also have some questions and we can discuss a little bit. What we would like to show you today is first the importance of virtual sensors in the software-defined vehicle stack, and then really digging deeper into the two use cases we brought with us today, headlight adjustment sensor replacement and also tire pressure sensor replacement. And at the end, I would also like to give you an outlook and also some insights about the strategic importance of hardware replacement and also the business impact of it. But let's get started. Maybe with some background information for the software-defined vehicle. I mean, we all heard about it, and software-defined vehicle is already in place for some OEMs, some especially the latest OEMs, maybe also NIO, Tesla, etc. say they are accelerating, they are coming into the market, and what we also see is, of course, the market dynamic behind it. And this is a study I found from Boston Consulting Group also, and they define creating value from software-defined vehicles. You can do this in three ways. So first, of course, as an OEM, you can do a superior product, which of course means that you have higher willingness to pay, you have really like a higher market share, and also increase the customer lifetime value. Normally, especially with SDVs, OEMs does this, of course, with new digital features and also a really digital seamless experience. And you can see the numbers already. Of course, it's distinguished between premium OEMs and also volume OEMs, but from a real SDV, you can deliver value according to Boston Consulting Group from 2,000 to 5,000 K. When doing this whole transformation to the SDV. This is if you really have an outstanding product and your product is just better than this from the competition. Then, of course, the second pillar is also the optimized bill of material. As we all know, of course, like with the SDV and all the software in place, there is the possibility to really optimize the bill of materials. I think when we are talking about sensors nowadays in traditional vehicle architectures, it's about 1K or more sensor signals and outputs we are having already in the car, and of course getting rid of them and also saving costs and also optimize the bill of material. This is exactly what we want to talk about today. And on the right hand side, of course, there's also the efficient enterprise. So the OEMs in general and the tier ones as an enterprise, of course, can benefit from this whole SDV stack. But let's focus on the middle, the optimized bill of materials. And there, of course, is like everything or everyone is also talking about reduced hardware costs, scalable software licensing, and also data-driven optimization. I think in the last years, these were some kind of trends with having a look on the current market dynamics. Of course, this is key to win in this market. And this is exactly where our solution comes in. When I say we are COMPREDICT. We are specialized in virtual sensor development, which means that we are producing ML-based virtual sensor technology, so intelligent algorithms, which are based on our know-how on of data science and also automotive domain expertise. We combine this to produce or calibrate our virtual sensors by and then having really valuable insights from the vehicle by just using already available CAN signals from the vehicle, which means you do not need any new hardware in a vehicle. We're just using what's already there. And then we integrate our software to give you the possibility to have completely new additional measurement possibilities in your vehicle, or to get rid of old and expensive hardware sensors. Our customers are automotive OEMs and tier 1 suppliers, and our investors, we are really happy to have Woven Capital, the investment fund of Toyota, since 2 months on board. So they are invested in us, and we were successfully closing our Series B. And also our latest announcement, maybe someone of you has already seen it 2 weeks ago. We are also really happy to announce that we will be part of every Renault, Dacia and Alpine till 2030, where we'll deploy our virtual sensors for tire and brake wear in series production vehicles for the Renault Group. Coming to the technology we are building. So what we are really doing is, as I said, virtual sensors. So on the left-hand side, you see hardware sensors, which are already in the vehicle. They produce a lot of signals, and we gonna use these signals to feed our algorithms. Our algorithms in the middle are based on data science, machine learning, and automotive domain expertise. And what we are doing is we are normally having measurement campaigns in place with the OEMs to calibrate the virtual sensors for the vehicles for them. And then after this calibration, where we have the vehicle CAN data and the reference data from actual hardware sensors, we combine it. And once calibrated, you can directly deploy the virtual sensor in the vehicle and get rid of the hardware sensor. So from this point in time, when you calibrated the virtual sensor in a measurement campaign, you never have to use the hardware sensor again with the same accuracy. And you see it already on the right, where we said, like, okay, we cannot only replace hardware, but we have a lot of use cases for this technology in the automotive industry. So we have the hardware sensor and replacement redundancy, where everything is, of course, about lower the total cost of ownership, reduce hardware dependency. Then we have additional measurement capabilities, where we are also able to virtualize really expensive R&D hardware for measurement campaigns. There we are talking, for example, about wheel force transducers, which costs about 150K per wheel. And you normally equip your vehicle with 4 of them. So you can, of course, also drastically reduce your R&D costs, especially if you want to have more wheel force transducer data than for one car, because you of course need for the calibration one reference vehicle equipped with it, but then once calibrated, as I said, you can deploy it to all the other development vehicles. And on the right hand side, there we have the health and usage monitoring. There, of course, also everything is about predictive maintenance, enabling after sales and generate new revenues. And then let me have a short look on the virtual sensor portfolio, and then Raphael will dig deeper into the tech and also the use cases of today. We are located in the left, hardware sensor replacement. We will talk about today about headlight adjustment and headlight leveling. Then tire pressure sensors, so really TPMS systems. And also what we have in our portfolio is like tire temperature, brake temperature sensor, and also e-motor temperature. So the temperature of the stator and also the rotor of the vehicles. When we are talking about the middle, about additional measurement capabilities, I already said that we are also capable of virtualizing wheel force transducers, the most expensive stuff you can do so far, I think, but also for strain gauge applications, for example, for tie rod forces, drive shaft torques, or damper forces, steering forces, all the stuff we can also virtualize. And on the right-hand side, as I said, this, for example, what we are delivering to Renault. The Renault Group is tire wear, brake wear, and then what's also in our portfolio is like vehicle mass and also low voltage and high voltage battery state of health. But let's dig deeper into the two mentioned use cases, and I hand over to Raphael.
Okay, thank you very much. So I'll deep dive into our headlight adjustment sensor first, and then we take a look at our tire pressure sensor. Headlight leveling adjustment will be mandatory from 2027. So all new passenger vehicles need to have this. You have to adjust the headlights automatically due to incline, due to acceleration, road conditions, to not blind people, basically. These systems right now work with two sensors. First, an ambient light sensor, which, of course, detects the outside light levels and costs around $5 to $15 per vehicle. I don't want to focus on that. I think this can be replaced in the future anyways with a camera. What we want to focus more is more dependent on the vehicle dynamics. It's the level sensor, which controls, which senses basically the pitch angle of the vehicle and costs around 10 to 20 euros per vehicle. How does it work? We use already available signals from the vehicle, so up to 15 signals are required, like for instance, wheel speeds, steering angles, and things like that. In these signals, you find artifacts of the we need to calculate the pitch of the vehicle. The optimal frequency is more than 10 Hertz. And we all feed this input data into our virtual sensors for headlight adjustments. First, we do a prediction of the vehicle mass. Depending on the vehicle mass, it has an effect when the vehicle stands still and has an effect on the pitch, of course. Then we have another layer of the virtual sensor, basically, which is a prediction of the dynamic suspension travel per wheel. Based on this, we estimate the vehicle's pitch angle, and this is the target value for the headlight adjustment. All right. There you can see a plot, a chart of how the virtual sensor works. The reference measurement is in blue. The virtual sensor is in orange. And you see, compared to the reference measurement, there's almost no deviation from the virtual sensor. Even in static situations, which is kind of hard to sense because there are not many signals coming from the vehicle in static situations, the virtual sensor still gives a good measurement of the pitch angle and the displacement of the wheels. The deviation, the RMSE, is 1 millimeter and below. So it's very precise. It's available for all vehicles. So if you're interested in that, do talk to us afterwards. The other sensor I want to show you right now is the tire pressure sensor. Tire pressure sensors are mandatory since 2007, so since a long time. Of course, for safety reasons and fuel efficiency. They're expensive, so it's around 15 to 25 euros per vehicle. So it's a great cost-saving potential, and we have developed virtual sensors which can replace these tire pressure sensors. This works basically the same as the other sensor. We have different input values the sensor use, which are standard CAN signals. So there's no hardware sensors, just 4 virtual sensors. And the accuracy is plus minus 0.2 bar with an RMSE of 0.11 bar. And as before, 15 signals are required, up to 15 signals with an optimal frequency of more than 10 Hertz. And with that, in the chart, you can see that the virtual sensor can predict the actual tire pressure very precisely. And there's a lot of cost-saving potential here to replace the TPMS sensor. All right, that's it. One more thing for the people who came later, we have a lot more sensors as Stefan showed before. So tire wear and brake wear are now in series production vehicles, in all Renault series production vehicles. All right.
Yeah, and then I will also, of course, give you a short glimpse on the business impact and also financial impact, of course. So what we can achieve and what we also notice, of course, also with the dynamic in the market is that like all the OEMs are forced to really reduce the costs, and hardware replacement, of course, is number one priority right now, to just save the costs, lower the prices, or increase the margin. What we have with our hardware replacement portfolio, where we not only have like the two sensors just mentioned, of course we have an improved reliability because it's all software, so we don't have mechanical failures and no and a more consistent performance. Also, of course, we have the supply chain resilience, which I think is really important nowadays also for all the OEMs, because it's software. We have a reduced dependency on hardware supply chain. And besides this, I would say really sometimes also obvious benefits from software itself, from the nature of software. Of course, you have like cost savings at scale. And what I brought also with me is like the savings if you really reduce these both hardware sensors, so the headlight leveling and the tire pressure sensor, with all the insights we are having from different customer calls and also sources, of course. It's like giving you a rough financial indication, which of course scales really with the serious production volume you are having at an OEM. But just to give you an example, of course, we have like in orange the bull case where you have about also accounting for all the hardware savings and the software costs already, have a cost saving of 35 euros per vehicle, which would be the orange line. And the blue case, the beer case, where you only have 5 euros per vehicle, which is maybe also more from a volume point of view. But here you see, of course, with 1 million vehicles produced, you can save up by replacing these two vehicles. You can save at least 5 million when talking about 1 million production volume, or especially for premium OEMs, of course, up to 35 million. And also with having this first proof, of course, also for our OEMs to replace this hardware, of course, there's the possibility to even increase this by expanding the portfolio of virtual sensors and even replace more hardware in the future vehicles. And now that's it. Coming to our point number 5, the Q&A. And of course, we are really happy to answer your questions. Thank you.
Thank you very much.